Hi, boys and girls. Today we're doing Chapter 9, Lesson 9, Problem Solving Using Logical Reasoning. So our learning intention is I am learning strategies for solving word problems so that I have many ways to think about problems to help me solve them successfully. So this is another strategy. This is actually kind of a fun one, I think. So anyway, the pages we're going to be doing, we're going to do all three together today. So we're doing pages 551, 552, and 553. So let's get started. We're going to use our 3-read strategy to help us with deciding what's going on in our word problems. And then whatever I write, you should write because that will help you be more successful with solving problems. Okay, so, this one's not going to lend itself well to the 3-read. So let's look at Sarah, Barb, and Aaron each wrote a different expression. The expressions were 3 plus 5 times 2, 3 plus 5 in parentheses times 2, and 3 times 5 plus 2. The value of Barb's expression is 13. The value of Aaron's expression is an even number. Which expression did each person write? Okay, so first of all, we're going to understand what we need to do. So what facts do we know? We know the value of Barb's expression is 13. It's right there. So I'm going to write 13 here. The value of Aaron's expression is an even number. Now, just to review, even numbers are any numbers that end in 0, 2, 4, 6, or 8, because those numbers can be divided evenly between two groups. So what do we need to find? We need to find which expression each person wrote. So I'm going to use logical reasoning to solve the problem. So let's find the value of each expression first. Now remember, your order of operations is you multiply or divide first. Well, you do whatever's in parentheses first. Then you multiply or divide first. And then you do addition or subtraction last. So looking at 3 plus 5 times 2, multiplication has to go first. So I like to put in my own parentheses. You'll have to excuse my desk robot. He's making noise. So I'm going to put parentheses around 5 times 2. So I know that 5 times 2 is 10, plus 3 more is 13. So I know this has to be Barb. Okay, now I'm going to do what's in parentheses first on the second expression. 3 plus 5 is 8, times 2 more is 16. Well, I'm looking at the digit that's in the ones place, and I see that it's a 6. That's an even number. So the person that does even numbers, I'm going to look back up at my problem. That is Aaron, so that must be Aaron's. So this last one, I'm going to put parentheses around the multiplication. 3 times 5 is 15, plus 2 more is 17. So that must belong to Sarah. Okay, so they made a little chart over here. 3 plus 5 times 2 cannot be Sarah, and it can't be Aaron because it has to be Barb, because Barb's answer is 13. 3 plus 5 in parentheses times 2 has to be Aaron because it's an even number, so it can't be Barb or Sarah. And 3 times 5 plus 2 has to be Sarah because it can't be Barb or Aaron. All right, so does my answer make sense? This is not working. Okay, he just knocked. Whoa, undo. There. No, that is not what I want. Okay, I'm just going to leave that line there because it keeps making my stuff disappear. Okay, so let's see if our answer makes sense. So we know that Barb's answer is 13. We know that Aaron is an even number, so it has to be Sarah. So I'm going to say yes. I'm going to type this because it's too hard. It's too messy to write with my finger. So yes, because when it says explain, remember you need comma because Barb's answer is 13. Aaron has to be 16. Let me make this smaller. My robot launched himself off my desk, so he's on the floor now complaining. He might be upside down. Oh, no, he's not. He's under the table behind me. Okay, yes, because Barb's answer is 13, and Aaron has to be 16 because her answer is an even number. Okay, so there we go. Okay. I wanted to lock that, but it's not letting. Oh, there we go. Lock. Okay. So let's go on now to the next page. Caleb, Ty, Joyce, and Lawanda each have one of 4 pets. Ty does not have a dog or a fish. Joyce does not have a bird or a fish. Caleb has a cat. What pet does each person have? So what facts do we know? So I'm going to type it here. Hopefully I'm more successful this time than the last time. Okay, so we know that Ty does not have a dog or fish. And we know that Caleb has a cat. And we know that Joyce does not have a bird or fish. I'm going to make it smaller so it fits. There we go. Close enough. Okay, what do you need to find out? Well, we need to find out what Lawanda has because they haven't even mentioned what Lawanda has. Nope. Messed that up. I need, whoa, not that kind of need. That's where you need bread. I need to know. I was thinking of the word know and need at the same time. I need to know what Lawanda has. Okay, so now let's look at the plan. Oops. So we need to make a table. So I will make a table. Make a table to help me solve this. So now I'm going to make the table. And I think it might be easier if I draw the table in this case because I'm still learning how to use this whiteboard. And I think drawing it would be better. So I've got 4 pets and 4 people. So I'm going to draw I need a 4x4 table, except I also need a place for my labels. So I'm going to make it a 5x5. I'm going to add 1 extra row and 1 extra column so I have a place to put my pets and my humans. Okay, so I'm going to make a giant rectangle. I'm going to make a column for my humans. I'm going to make a column for each of the pets now. So I have 1, 2, 3, 4 columns. So now I'm going to make a row to put the kinds of pets that there are. And then I'm going to put a row for each human. 1, 2, 3, 4. Okay, so my humans are Caleb, Ty, Joyce, and Lawanda. And I'm just going to use their first initials. I'm not going to write it in my first row because that's where I'm going to put the names of the pets. So Caleb, Ty, Joyce, and Lawanda. Okay, now I'm going to go back up here, and the pets are dog, fish, bird, and cat. Dog, fish, bird, and cat. All right, you know what I'm going to do? I'm going to make this a little smaller so I don't have to keep scrolling. Because now all I'm doing is putting yes and X's. And I'm going to move this out of my way. Okay, so we know for sure that Caleb has a cat. So I'm going to go ahead. I'm going to switch colors too. So Caleb has a cat. So Caleb is yes for a cat. Okay, he does not have a dog. He does not have a fish. He does not have a bird. He also, this does not look like a very good Y. Let me make it like that. Oreo, stop. That's my dog. So the cat cannot be owned by Ty, cannot be owned by Joyce, and cannot be owned by Lawanda because every person has a different pet. Okay, so now Ty does not have a dog or a fish. So let's put an X for dog and an X for fish in Ty's row. So he has to have a bird. So I'm going to put a Y there, and then I'm going to X it out for Joyce and Lawanda because they can't also have birds. Okay, now Joyce does not have a bird or a fish. We already know Joyce doesn't have a bird. So now we know she doesn't have a fish, which means she has to have a dog. Which means Lawanda cannot also have a dog, but Lawanda, nobody has a fish except Lawanda. Okay, so now let's check. Does our answer make sense? Explain. Well, yes, it does, because we already know that Caleb has to have a cat. Okay. Yes. Yes, comma, because Caleb must have a cat. Joyce has to have a dog. Oops, what happened? Okay, and Ty must have a bird, not a girl, a bird. Okay, I'm going to make this small so you can see it. So, Lawanda must have a fish. There we go. Okay, let's go on to the third page. Let me lock this in and move on to the third page. All right, so Marley places her language book next to her science book. Her math book is next to her reading book, which is next to her language book. What is one possible order? Okay, so she has her language book, her science book, and her math book. And apparently she lays them all out on her desk. So we're going to go ahead and draw this. So her language book is next to her science book. Okay, and her math book, and we also have a reading book. And her math book is next to her reading book, which is next to her language book. So the reading book is next to the language book. And her math book is next to that. I wonder if I can move this over as one unit. Nope. Okay. All right. So it's out of my little box there. So this is one order that it can be in. Okay. So her math book is first, which is next to her reading book. Her reading book is next to her language book. And her language book is next to her science book. So one possible order is math, reading, language, then science. There. Okay, let's go down to the next one. 3 friends will put their money together to buy a game that costs $5. Dexter has 5 quarters and 6 dimes. Belle has 6 quarters and 8 dimes. Emmett has 5 coins. If they have 10 cents left over, what coins does Emmett have? Okay, so the game costs $5. They're going to have 10 cents left over. So let's first find out how much that is. So the $5 game minus 10 cents. So I'm going to subtract in my ones place. 0 minus 0 is 0. 0 minus 1 I can't do, but I can borrow from the 5, make it a 4, make the 0 into a 10. 10 minus 1 is 9, and 4 minus nothing is 4. So $4.90 is what they have left. Okay, so let's decide what we know. Dexter has 5 quarters and 6 dimes. So the way I like to draw money is to just put the first letter of that money as the coin. So 5 quarters, quarter, 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 and then 6 dimes. Dime, 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 dime. Now, I know that quarters are 25 cents, and if I have 4 of those, it makes $1. So I'm going to put a rectangle around this so I count it as $1. Now, this quarter here is 25 cents, so we're going to start counting with 25, and we're going to skip count by tens for every single dime. I'm going to make a little dot by them when we count them. So 25, 35, 45, 55, 65, 75, 85. $1.85. So I'm going to subtract from $4.90 $1.85. So again, I'm going to subtract in the ones place first. 0 minus 5. You can't do that. So I'm going to borrow from the 9 and make it an 8. Make this a 10. 10 minus 5 is 5. 8 minus 8 is 0. Decimal point. 4 minus 1 is 3. So I have $3.05 left. So I've already done Dexter. I'm going to cross this out. Okay. I've already done the 10 cents left over too. Okay. Belle has 6 quarters and 8 dimes. So now I'm going to switch colors so we don't get confused. Here's Belle's money. She has 6 quarters. 1, 2, 3, 4, 5, 6. And then she has 8 dimes. 1, 2, 3, 4, 5, 6, 7, 8. Okay, now I'm going to make a rectangle around 4 quarters because that's $1. Now I'm looking at this and I see that 2 quarters make 50 cents, and I definitely have more than 50 cents here in dimes. So what I'm going to do is I'm going to take my 2 quarters, which are 50 cents, plus 5 dimes, which are 50 cents, and make that $1. So here's my 2 quarters, and I'm going to count over 5 dimes. 1, 2, 3, 4, 5. There are 5 dimes. Okay, so now I have 3 dimes left. That's 30 cents. So I have $2.30. I'm going to subtract that from this problem. 5 minus 0, starting in the ones place again. 5 minus 0 is 5. Down the tens place, 0 minus 3, I can't do that. So I need to borrow from the $1 place. And actually, this is the pennies place and the dimes place. This is the $1 place. Forgot I was working in money here. Okay, so I'm going to borrow from the 3 and make it a 2. And I'm going to take those 10 dimes from the dollar and put them over here. So now I have 10 dimes here. 10 dimes minus 3 dimes is 7 dimes. Need my decimal point. 2 minus 2 is 0. You can put a 0 in the $1 place. So now I have 75 cents left. So I did, Belle has 6 quarters and 8 dimes. I did that one. So Emmett has 5 coins. I need 5 coins that equal 75 cents. Well, I know that 3 quarters is 75 cents. So I know it can't be the 3 quarters. But I can take 2 quarters. Let me grab a different color. Okay, so I'm going to use 2 quarters. I'm going to see if splitting 1 quarter into 2 dimes and a nickel is 5 coins. Okay, because 2 dimes is 20 cents plus 5 more, and that nickel is 25 cents. So there's 2 dimes and a nickel. Let's count and see how many coins I have. 1, 2, 3, 4, 5. I have 5 coins there. So what coins does Emmett have? Emmett has 2 quarters, 2 dimes, and a nickel. Oops, hang on. Okay. Emmett has 2 quarters, 2 dimes, and 1 nickel. Okay, now Rod is less than 17 years old. The sum of the 2 digits of his age is even and greater than 4, but both digits are odd. How old is Rod? Oh my goodness. So we know that Rod is less than 17 years old, which means he can be any number up to 16, but that's it. But there's 2 digits in his age. So we know he can't be 0, 1, 2, 3, 4, 5, 6, 7, 8, or 9, because those are single digit ages. So there's 2 digits in his age. So we need to write down all the possible ages that he could be. So he could be, I need a totally different color because this workspace over here is getting pretty cluttered. So let's see, what can I pick? I'll pick this purple here. Okay, so he could be 10. He could be 11. He could be 12. He could be 13. He could be 14. He could be 15. He could be 16. So now I'm going to add the digits up because it says the sum of the digits of his age is even and greater than 4. So it has to be even and greater than 4. But both digits are odd. Yikes. Okay, so both digits are odd. Let's go with this one first. Both digits are odd. So let's take out the ones where it has an even digit. Remember, the even numbers are 0, 2, 4, 6, or 8. So I'm going to go through and I'm going to cross out the ones that are that have an even digit. So 10 has 0, which is an even digit. 12 has 2, which is an even digit. 14 has 4, which is an even digit. And 16 has 6, which is an even digit. So he's either 11, 13, or 15. So now I'm going to add them up and see which one has an even number for the answer. Okay, so 1 plus 1 equals 2. So he could be 11. 1 plus 3 equals 4. So he could be 13. And 1 plus 5 equals 6. So he could be 15. Okay. So how old is Rod? Well, he's less than 17. The sum of the two digits of his age is even and greater than 4. Okay. So 2 is less than 4. 4 is equal to 4. So Rod has to be 15. Rod is 15 years old. All right. Now, rolling on down here. Jan is 3 inches taller than Dan. Ellie is 3 inches taller than Jan. If Ellie is 54 inches tall, how tall are Dan and Jan? Oh, I think my head's going to explode. Glad there's only 4 word problems here. Okay, so Jan is 3 inches taller than Dan. So I'm going to pick a totally new color here. Let's see. Pick orange. Not one of my favorites, but it'll work to make it stand out. Okay, so Jan is 3 inches plus Dan. Okay. Ellie is 2 inches taller than Jan. So Ellie, let's see, let me do this. Jan is equal to 3 inches plus Dan. Ellie is equal to 2 inches plus Jan. So if Ellie is 54 inches tall, how tall are Dan and Jan? So let's substitute that. So Ellie is 54 inches. I'm going to write it over here on the side. Actually, I can do it here. 54 inches. Okay. Her 54 inches is equal to 2 plus Jan. So if we subtract 2 from the 54, that gives us 52 inches. 52 plus 2 is 54. So Jan is 52 inches. And so if Jan is 52 inches, she's 3 plus Dan. So Jan is 52 equals 3 plus Dan. So if we subtract 3 from 52, then we will find out how tall Dan is. So remember, in order to find that missing addend, you have to subtract. You have to use the inverse operation. So 2 minus 3, we can't do that. So we're going to borrow from the 5 and make it a 4. The 2 becomes a 12. 12 minus 3 is 9. 4 minus nothing is 4. So Dan is 49 inches tall. Inches. Dan is 52 inches. Okay, and we can plug this information in backwards to make sure that it's right. So let's do that. Okay, so back up here to my first number sentences. Okay, so Dan is 49. 49 plus 3 equals 52. So Jan is 52 inches. And Jan, being 52 inches, plus 2 equals 54. So Ellie is 54 inches tall, which it says right here. So we did it right. There you go. Those are fun. But yeah, that's a lot of work. And my brain is very tired.